Hello guys, welcome to this session on AWS Cloud Basics. So our responsibility is not just knowing the names of databases. So we should understand how the core concept of cloud directly so our kind of legacy kind of on-premises bottleneck means and fault tolerant risk. Okay. So that's what we need to take care. So now, first of all, what is the cloud computing, and kind of what are the core values of cloud computing? So when designing a business case for migration or some greenfield cloud architecture, so your system designer must use user advantages of cloud computing. So if you are going to design a cloud application exactly like an on-premises data center, so in that case, you can find as the architect of the cloud architect. And here, there is a kind of architectural shift as well. Okay. So in on-premises data center, you are going from static capacity to hard limit, and which can lead some outages or in case some cases like resource wastage. And on the other hand, AWS cloud is like using elastic scaling, which is dynamic, and which is uh, going to be for the cost saving as well. Now we have some of the benefits. So the first benefit is kind of on-demand delivery of kind of IT resources. So in and traditional enterprise environment, if a development team needs some 64 core servers with 256 GB for an AI workflow, the procurement cycle that can take weeks or months. Okay. So in AWS, this infrastructure is treated entirely as a software. So here, you provision compute, storage, database via API calls or some scaling commands, or also you can say say using some IAC templates, and that you will do in seconds. Okay, and this procedure is going to completely change how we think about we are going to test some environments. Okay, so we can spin up an extra replica of production, or we can say test a major patch, or we will tear down within some in 1 hour, or maybe less than 1 hour as well. So the next uh, like uh, benefit is kind of you will pay as you go. So here you are going from capex to opex. So in all premises kind of architecture that demands capital expenses, that is capex, that is massive upfront investment. So you need to a massive upfront investment in physical servers and real estate, uh, cooling system, and in kind of networking switches. Like it is before a single line of application calls to run. Okay. So AWS is going to shift this particular system entirely to operational expenses, that is OpEx. So here, you pay dynamically for exactly what you consume, and it is going to measure down to the seconds of compute or gigabit or gigabyte of storage. So this is going to eliminate the capital loss. So if a proposed application architecture kind of fails to gain some business value, so in that case, you can create the cloud resources, and like uh, the financial burdens can be stopped immediately. And the next one is the store caching capacity. So this is kind of the greatest feature that might or you can say this with the on-premises infrastructure, the greatest feature is kind of planning or sizing. Okay, if you undersize your application class is during peak event, like some sensitive. or if like you oversize to handle peak loads, so you end up kind of paying for thousands of idle processes that are running at 5%, okay, during the rest of the year. And AWS is going to allow you to build some elastic architecture. So you design like baseline capacity using auto scaling groups that dynamically like expand during high traffic spikes and shrinking like down when the traffic is going down. So you are going to optimize a particular post. And after that, we have like some more advantages like global reach, okay, trade fixed expenses for variable expense and kind of increased like speed and kind of agility. So like deploying an application globally and like used to means like entering a like multi-year contract with international data center. So with AWS, you can replicate your entire software stack globally across multiple like continent and minutes. So this is going to reduce like geographic latency for international users and so going to enhance like business agility as well. The second phase is kind of AWS deployment model. So here like AWS accommodates like three core deployment patterns based on kind of security mandates, the regulatory compliance, and kind of legacy application constraint. So here we have public cloud, hybrid cloud, and private cloud. Okay. So you can say public cloud or like this is all in a place. So in this model, like each kind of every components of this ecosystem lives entirely within the public AWS cloud infrastructure. It allows you to take full advantages of cloud native efficiencies like serverless computing, decoupled microservices, and fully automated multi-agent application. So it applies to both brand new, like greenfield projects or like fully kind of completed lift and shift migration as well. So second, we have the hybrid deployment. So hybrid models maintains an active network connection between your existing on-premises data center and your public AWS cloud environment. And this is the most critical kind of reality for large enterprises. So here you utilize like secure connections like AWS Direct or site-to-site VPS. And this is either for kind of a phased multi-year migration plan or for cloud bursting topologies like where steady state or transactions are handled by a legacy on-premises database. But the web front end scales dynamically out to AWS to handle like user traffic spikes as well. And the third one is the on-premises or kind of private cloud. You can like use AWS Outpost for that. And this model brings native AWS hardware APIs tools directly into a physical on-premises facility or like a co-location space. So this is necessary for edge cases like where data loss says that information may not be like physically cross geographical quotas or kind of for heavy industrial systems like factory automation or real-time medical imaging, where like single digit like millisecond latency is kind of mandatory. That's here, like in section 3, we have the AWS infrastructure and kind of resiliency. This is kind of the most critical section of them. And like to build highly available fault tolerant disaster resilient system, you must design with a solid understanding of the physical layout of AWS like Azure global network. So here, like if you talk about the AWS regional boundary, inside regional boundary there are availability zones, and inside the AZs there are kind of multiple data centers. Okay, like suppose in region we have two AGs, zone one, or we get a zone A and zone B. And inside that, there are data center inside the one here. That will be data center one and data center two. And these are connecting via some high speed kind of fiber links. Okay. So now let's talk about that AWS region. So AWS region is kind of a distinct separate physical geography location on the globe. For example, US East one in North Virginia or EU Central one in Frankfurt. And like here, regions are entirely separate from one another. So data does not move between the regions unless like you build some cross regional application. And when picking a region for your application, always balance three parameters. That is compliance, one is it data residency loss, that proximity, like you can reduce like latency by keeping compute close to your users, and the cost or feature availability. So here like pricing varies like between regions, and like some services like could not be present in some regions. Okay, so you should keep in mind that as well. So then we have agile, so it is availability zone. So an AG is not a single data center. An AG consists of one or more discrete physical data centers. And here, like each equipped with its own independent net power infra. Uh, it's like cooling system and like network routing fibers in a specific within a specific region, you can say. And all edges like within a region are interconnected via ultra low latency like private high speed fiber optic mesh. And as an architect, your default region standard must be multi-AG. If you are going to deploy AC instance or database only by one AG, your infra like has a single point of failure. And by splitting your application across multi-AG, you ensure that even if the entire power grid failure drops the entire zone, your application like cell is continue running from zone failures. Okay, like around you can check on time. Then we have the edge location. So here, like edge locations are a separate network or for enterprise deployed outside of the AWS primary region. Like they power kind of Amazon CloudFront, which is AWS Cloud Content Delivery Network, or you can say CDN. So edge location are kind of these like caches static assets like images, video files, or some CSS sheets, and it is going to accelerate dynamic API queries directly to the edge of the internet, or you can say physically closer to where the end user sits. Okay. And this is going to reduce the TTFB, that is time to first byte, and protects your core application like from heavy traffic as well. And in the last section, we have some like main services of AWS. Okay, like we have for compute we have EC2, for storage we have C3, for database we have RDS, and we have and like for serverless computing we have the AWS Lambda as well. Now, if we talk about the Amazon EC2, that is Elastic Cloud Compute. This is the kind of traditional infra as a service, IaaS, you can see. So EC2 is like going to be secure, resizable, virtual machine. So here, like you have a full root or admin control over the OS. This means like you are responsible for OS level security patches, network firewall rules, security groups, and scaling policies. So you can use EC2 when your application requires a customized OS configuration, or like you are going to use like legacy software packages like that cannot be containerized. Another one we have Amazon S3 for simple storage services. So this is the object storage services to store and retrieve any amount of unstructured data from anywhere on the web. S3 is like going to provide 11 lines of durability, by automatically replicating objects across a minimum of three distinct physical edges inside ANZ. You can use S3 as your central data lake repository for system backup or for hosting decoupled static web application directly to the internet at kind of minimal cost. Then we have the Amazon RDS or relational database service, so which is a managed service that makes it easy to set up, operate, and scale traditional relational database, including MySQL, Postgres, SQL, and MariaDB, Oracle, and kind of Microsoft SQL Server. And here, like RDS abstract away the heavy lifting of database administration, and it is going to automatically handle OS patching, hardware provisioning, storage, scaling, and automated snapshot backup. With a single checkbox, where you can enable multi-easy synchronous application so that like it gives you data to your instant and database failure automation kind of features. Then we have the innovation of that. So it is kind of event-driven on the serverless architecture. And with Lambda, the entire underlying host infra is completely invisible to you. So you are going to upload your raw code footprint, and AWS execute is it like purely in response to event trigger that could be uploaded the file on S3 or an API gateway call. And here, like you never patch the server, you scale seamlessly to thousands of content requests, and you are going to pay only for the exact milliseconds you have code runs. So it is kind of ultimate tool for like minimizing operational overhead and kind of idle resource cost. So like as you begin designing architecture on AWS, you should remember that like your primary challenge to balance these components. So you must leverage like global infrastructure for high availability. Select the correct deployment mode and to match the compliance boundaries. And then you need to use the combination of managed RDS, S3, and those kind of serverless services to drive that operational complexity. And I think that's it from this particular session. Thanks. Thanks.